way in this class is to recognize if something's linear or not linear. We want to be able to recognize that from a graph, from a table, and from an equation. Let's start with a graph. How can you tell if a graph is linear? For example, is this graph linear? Pretend I did draw a straight line. Yes, this graph is linear. And we know that because the rate of change is constant. What about this graph? This is a graph of a parabola. It is a function, but it's not linear. The rate of change is not constant. It's negative and steeper in some areas, and shallower and positive in others. So if a line is straight, it represents a linear equation. How can you tell that a table represents linear information? This is a little bit of a review from when we talked about slope, but what we essentially want to do is we want to look at the rate of change and judge if the rate of change is constant. Keep in mind, you must reduce your fractions. So the step between 18 and 12 is that's a change of -6. Between 12 and 9 is a change of -3. In the x values, the change between 3 and 5 is +2, and between 5 and 6 is +1. These numbers are not all the same, but what we're interested in is the ratio. So for this first one, the ratio, or rate of change, or slope, is -6/2, which reduces to -3. For the second step, the ratio of change is -3/1, which reduces to -3. Since these are both the same, this is a linear relationship. Let's look at the next table. Going from -16 to -14 is an increase of 2. From -14 to -12 is also an increase of 2. Let's look at the change in the x's. Going from 1 to 3 is an increase of 2. From 3 to 4 is an increase of 1. I can tell right now this is not going to represent a linear function. The slope of the first, so the rate of change of the y divided by the rate of change of the x, is 2/2, which simplifies to 1. For the second step, the rate of change is a 2/1, which simplifies to 2. Since these are not the same, not equal, this is not a linear function. For an equation, let's look at these 5 and judge if they're linear or not. For an equation to be linear, it can be written in the form of y = mx + b. Notice there's no exponents. We're not dividing by x. So let's look at this first one. 2x - 3y = 6/5. If I manipulated this equation, I could write it in y = mx + b form. This is a linear equation. This next one, if I tried to write this in y = mx + b form, I would need to get the x out of the denominator. I can achieve that by multiplying both sides by x. That would give me xy = 2. X's should not be multiplied by y. This is not linear. This next one, y = 4/3 x + -1, is linear. It's already in y = mx + b form. The fourth one, I notice it has an exponent of 2. That right there tells me that this is not linear. Notice that the numbers, like 17/6 and 6/5, the numbers could be ugly. Or I could put in something like -5 squared. That would not impact its linearity. It's the exponent on the variable. So this last one, it looks so close to y equals 2x minus 7, which would be linear. But since it's y squared equals 2x minus 7, it is not linear. So again, what we're looking for is for something to be able to be written in y equals mx plus b form, even if m or b is 0. Thank you.